Got my Dunkin' decaf to go. I just did a 40-minute video for technically no reason. Practice, I guess. So we'll do this again. Common rail injection systems, okay? I'm going to try and simplify it for you because, believe it or not, while you're sitting there, oh, this is new and different. The only thing that's different is the control parts. Your governor is gone mechanically and becomes a controller, computer, telling your system what to do based on guesstimates on load. And it's basically the same as a governor. When you turn your throttle, move your throttle, you're telling a spring what to do, and the spring tells the governor what to do. Then the condition of the engine, there's a balance, and that's all you're looking for is the balance. Well, the controller has algorithm in it that operates just like the throttle, spring, controls, whatever. You give it an input feed, how much throttle you want. The engine has a range that it's designed just like your diesel systems, your idle and your full throttle, and your smoke screw. Well, that's all built into software program now, but little bitty signals that are sent. But the controller does something else that your pump did 100% mechanically before too, and that is fuel delivery. Or your pressure was variable before. You know what's scary? Your injection pressures are variable now, only instead of being varied strictly by load and governor setting, you know, how much fuel it's putting through and by the smoke screw, and et cetera, and your RPM. Well, you know how to adjust that. Almost everybody does anymore. You just need to know which screw to turn. You turn the wrong one on a Bosch P7100 pump, baby, you're going to be hunting a surgeon like Elmer Fudd. So the controller takes care of that here. But I want to semi-simplify the system for you. Now, what they are, the most problems that I want to talk about are level 1 and level 2 on your fuel warning systems. So you're driving along in your tractor and it pops up and says low rail pressure. There could be a dozen different numbers for it. Cummins' old numbers used to be 559 was level 1, and I think 2341 was level 2. Level 1, you may or may not even notice a hiccup. Now, for each code to set, it takes 3 events. So by the time you get the warning, it's happened 3 times. You don't know how. It's usually within a certain period of time, and it's different for manufacturers and codes. Usually it's 3 set within the last, probably, say, minute of running time, I'm going to guesstimate. Because normally that's about what I used to have to sit there in the seat and go through before it would set a code. I know the code's there. The engine's given me some funky feelings and funky RPM readings, et cetera, but it'd take a little bit, and then ding, the code would pop up. And I'd say roughly a minute. It's different for however they set the software. So when it reaches that level 1, it'll be minor to almost nothing. That just throws you a level that says you got a problem here. Okay, that's level 1. What does level 1 do? Well, level 1 is telling you that seriously what the code is, the pump is working too hard to maintain pressure in the rail. Doesn't even care about the injectors or anything else. The hiccup you're getting is the lack of fuel delivery. If you get a lot of hiccups, it's going to go into level 2. There's a heater here. The cat loves to lay on top of the heater. I've got a cage over it. He's funny. Anyway, so level 2 is you've had trouble. You're going to notice what it is, and then level 2 pops up. And sometimes you've already hit level 1, and if it's bad enough, soon enough, it'll just go straight to level 2. Level 2 is a severity level, and probably it'll put you into limp mode so it doesn't overwork the pump. All right, now that you know that about the 2 codes, what can cause that? Well, let's step back a little bit. Even though it's a common rail system and looks totally different than what you used to have, the operation of the system is identical to what it's been since I can't say since the inception, because we don't run on coal dust anymore. Yeah, the earliest diesels ran on coal dust, some of them. They would actually throw the coal dust into the cylinder, and as the piston came up, it'd get it hot enough to fire the coal dust. Anyway, oh yeah, they got the wrong coal dust in there, and they blew up 3 city blocks a couple times. The old Germans, they'll try anything once back then. So, but start your fuel tank. With our Komatsus, the systems I was familiar with on the dozers, they used to have it because of their environments worse than almost any other machine out there. On the Komatsus, they all had a screen down below the tank, a catch screen for all the trash that was going to be in the tank. The tank was open and exposed in general. You had to fill it from the back. You had to stand up, and there was just a lot of stuff that when you took that monster cap off to fill that thing, that would cause a problem. So they had your shutoff valve and a screen that can plug either one of them, right? Now you've got your line going up front, and you have to check the flow through the line. Most of the time, the lines or hoses don't cause much trouble, but in cold weather, they can. So that's where you're starting. In the tank, can it get through to the valve? Can it get through the valve? Can it get through that little screen? If the screen isn't there, some of the other systems, you got flow all the way down through under your cab and up into the filter head or to it. But something's wrong. You got a funky pressure reading at the filter. Almost all of them have on the primary filter, because it's suction side usually. Not all of them, but a lot of them are. And there'll be pressure test ports on either side. And if you're testing there, you're getting funky readings. On the one side, you get high vacuum. The other side, you don't. Well, it depends on whether the filter's plugged or not, whether it's a pressure primary or a suction primary. Usually, the primary side coming into the transfer pump doesn't have much of a filter on it. It's normally from the tank, from the screens, up into the pump, around the pump. And quite often, some of them will have the primary filter in the suction side. That's the best way to do it. So you're checking vacuum on either side to find out if it's the filter or back to the tank. If you get the same reading on both sides, then you know it's probably before the filter. That's one way to look at the trouble they have here. So it's similar to your old stuff. You can test your vacuum, your flow rate, and your pressure before the pump. The little transfer pump that's on the main pump. Yeah, John Deere also has a transfer pump like the old systems on the side of their blocks on a lot of these machines. So you have to check there for leaks, bad check valves, and for screens being plugged, because quite often they're banjo fitting with a screen in it. On a lot of primary filters, you pull the banjo fitting out, there's a screen in there. Check, see if it's plugged. Or the banjo fitting alone can be plugged, especially from filter media. Filter media from your fill tank that often has a filter on it if you're running a good system. And if it isn't changed often enough, it comes apart and goes through and plugs things up. It's a mess. It can be. Yeah, you want one on your fill tank, and change it often. It's expensive. So is a breakdown. So is a plug system. So is a service call at $150 an hour anymore. Just saying. So you've got the same transfer style stuff that you would have on your old systems. Yeah. Go to your American Bosch pumps on your internationals. Transfer pump was on the back of that pump, wasn't it? They're on the pump. Same idea now as the Bosch pumps were. True story. So then some of your P7100 and Denso pumps, the inlines, the pump was on the side of the body. So, follow the leader here. And just follow through the system going up to the filter head. And now some of these, if they have banjo fittings, what I used to have to do is, if it's an open banjo fitting, you drill it, you buy a secondary, drill a hole in, put an 1/8-inch pipe fitting, or a nipple of some sort. And suction side, you're testing vacuum, so you just need a good fit. You can pull a fitting off, and some of them on the filter head will have plugs on them. And so match the plugs and hook a gauge up to it. It's worth your time, especially if it's banjo fittings. Go down to your dealer, order an equivalent banjo fitting, drill it out, and put a fitting in it. If you got enough meat, put an 1/8-inch fitting in there, or braze a piece of brake line in there. Just put a minor flare on the end, a hose clamp, put the thing in there. It's worth it. You'll save your time. By the time somebody comes in and tests your fuel system and has 4 hours involved, then suddenly you've got $600 plus travel time, plus truck time, plus environmental. Shall I keep going with the pluses, the miscellaneous charges and stuff? When you start pressing up to $800 to $1,000, and what have they done? Showed up. Travel time, $1,000. What do? They tested your system. You went out and spent $200 for fittings and used your own time to test some of the system before you called them. It's worth it. Now, when you're coming up through your standard system to your pump, now you're testing the pump head itself, the high pressure head, with fuel coming into it. Is that at the appropriate pressure going through? And some of this you can, once you start getting past the vacuum side, which you need to test running if you can, then your hand pump there will tell you whether your primary relief is working well enough or not to get the proper pressure to the head. The old systems only needed 10 or 15 pounds of pressure coming into them. The later systems that started getting into the high pressure distributors and such, your emission systems, some of those needed 40, 45, 50 psi coming into them. Well, some of these systems need between 20 and 25 coming into them. So once you started getting into certain systems here, even the old systems that are computer controlled, they still needed pressure coming into them. The only one that's an oddball is a little pump that John Deere has that's specific from Stanadyne, and they still use the John Deere transfer pump, which is 5 to 15 psi. That's all it needs coming in, because it takes care of itself once it gets in there. And these are similar too. But you want to test your vacuum, you want to test your primary pressure coming into the pump, and then you test your leak-off pressure going to the pump, which is the same as the head pressure going into the pump through your filters. Your primary filter, which is often suction, as I say, not every system, but most. And then another one, your secondary, your 10 to 20 micron primary, and your 2 to 3 micron, maybe as high as 5, is your primary or your secondary filter, the real one. Then it goes from there into the injection pump head. Well, just call it the common rail pressure pump. But it does the same work as the old injection pumps did, rotary or inline. Same idea. It's pumping to make pressure, only now they're storing the pressure. Goes from there, 1 or 2 lines, into your common rail. Then they call it stored pressure, because if you're cranking it over, it draws the fuel in, fills the rail up, reaches a pressure point, and then the controller starts running the injectors. Well, now I have to get Debbie. And when it starts running the injectors, you start, electronically popping them open. But there's still poppet nozzles down here at the bottom, same as your old system. However, at top, they have a little valve that closes things off, and fuel is held in there on both sides of that little poppet panel. Well, what's that valve up top do? It opens the return, unbalances the little pinhole, and then it pops just like an old-fashioned injection nozzle. Same basic design style. It really is. However, that little valve up top is where a majority of your problem is. When you get your codes, your level 1 and level 2 codes, saying, this ain't good and this is really bad, those are your 2 codes. This is poor, this is horrible. Level 1, poor. Level 2, horrible. And not all of them, but where are you looking at first? The first thing you're looking is just what we did, fuel coming up to the pump. Do you have low enough vacuum, which is usually below 10 to 15, usually below 10 inches of vacuum. Just take your old-fashioned vacuum gauge that you'd put on an engine, and it's usually inches of mercury, but you can put that in the system, check the vacuum. Just the old round little, it's only 15, but you need to be below that on vacuum. And then you get up to your transfer pump. Make sure it's low vacuum all the way to there. Test a couple places along the system. You find out vacuum good, vacuum bad. Okay, now the vacuum is just before it. So you're checking your filter on both sides. That'll give you an idea. Check it on the inlet side of the filter, and then go on up to the transfer pump. Test it if you want. You sometimes have to take your banjo fittings, drill them, put a nipple in the end there, and you can test from there. Or they'll have a T fitting you can put in. There's a lot of stuff you can do depending on your system to check for your vacuum. Then test the output side from the transfer pump to the pressure head of the injection pump. They say, well, that's no. You remember some of your old pumps used to have a little transfer pump on the side of the injection pump. Same idea, just that it's usually a G rotor or vane pump on the back side of this thing. Same principle. This one's a little piston pump doing this, and that one's a one inline or rotary. It's piston or G rotor, gears or vanes. You're just moving fuel. But now your pressure head generally wants to be up someplace around, usually the 20 to 45 psi range. It can be broad because most of these engines are running fuel coming in between 10 and 50 without a problem. But they won't give you full power when they're down on the lower end. I know a guy that was used to jack the pressure up of 45, 50, and 55, 60 pounds coming in thinking it really boosted. Well, it doesn't do a thing for it because the controller takes a fuel rail. And he says, oh man, it really made him go. Well, no, it doesn't, because a fuel rail reaches a pressure that's commanded, that the controller wants. It shuts the pump off. So just get fuel to it within the range they want. That's it. Now, what are you checking for leakage? Return from your injectors is the first place. There's a return line, and there's usually a procedure and fittings and such to check how much fuel is coming from the return lines into a beaker. Put the beaker in a bucket. Okay? So that you run it, the fuel starts coming out, put it in a beaker, run it for the time period allotted, 30 seconds, a minute, and in the instant the time's up, take it out. You've got your fill, shut your engine off. You're not worried about shutting it off too soon, messes or anything else. You can do that with your pressure relief and your return from the common rail pump itself. And those are the basics that are going to take care of you. Hi guys. Where's my little guy? So, and after that, you're checking your filters and everything else. Now your wiring harnesses, why are they getting replaced like Andy at Farm Fixing and Fabricating? No, because wires can bleed over on top of each other and throw signals for a problem that doesn't exist. So you end up with a wiring harness that either has a bad connection or bleed over from two wires running too close together where one's running either high voltage or high amps through it. Injectors are fired on 50 volts roughly, give or take anymore. Should have seen us back in the Komatsu days with the early common rail where they had 100 volts running in the injections. Had a lot of bleed over and a lot of codes that didn't need to exist. We tightened the harnesses up and tied them down tighter. Problem solved. That's sad, but that's a true story. So go over to Farm Fixing and Fabricating. He can help you out. ZK Master Tech, as I had said before, and then Warren up there at Western Truck and Tractor. Those guys can help you out a lot here on YouTube as well. ZK just went through a system test, and that might help you out as much as anything else, where he actually had to individually cap the lines out to find out which injector was bad. He found out which one was bad. Every one. See ya.